We're here for the final event of eNeuron. Thank you also to the people connected online. Before giving the floor to the project coordinator, I'm just gonna say a few words about these few hours that we have together. So for the people online, please put all your comments in the chat, or if you also want to speak, raise your hand, and then we will give you the floor. And for the people here in person, if you also have a question, just raise your hands and we will come with the microphone, okay? All right, so we are going to spend the next few hours together. Now I'm going to give the floor. This is the agenda, but now I'm going to give the floor to the project coordinator for a few words. Okay, thank you, everyone.
Good morning, everyone, and welcome to the final event of eNeuron. I'm very happy to share this day with you because this day marks an important milestone of the project. This is the conclusion of our project, 4 years of hard work and a fruitful collaboration between the consortium partner, the stakeholder, and also the advisory board members. I won't go through the okay. I will not go into the details of the project, but I'd like to say that we have reached all the goals of the project, and we have tried to design and develop this toolbox for the optimal management of energy communities, but the optimal management of the energy communities in the real world. We have tested all our solutions in 4 demo sites, and so we have experienced all the challenges and issues that have to address the ones that would like to integrate the energy communities into the real world. So this means that we have addressed the problem of interoperability. We have experienced the different local regulatory framework. We have also experienced the difficulty to find accurate input data for validating our solutions. We have tried to propose a new solution, advanced solutions and so the lesson learned from overcoming these issues are part of the legacy of the eNeuron project. We will share with you all deliverables of the project through our website, so you can find what we are going to propose to solve the problem of integration of integrating the toolbox for the optimal management in the real environment. So thank you for being here, and thank you. I hope this will be a fruitful day for all of us. And now I give the floor to Cristina and José. Thank you.
Hello, everyone. Good morning. I would like also from my side to welcome everyone in this event. My name is Cristina Papadimitriou. I'm an assistant professor at TUE and the technical coordinator of eNeuron. On my side, I'm going to walk you through the idea of eNeuron, when and where it all started, and then I am going to focus on the conceptualization of eNeuron toolbox before giving the floor to my colleague from ENEIDA, José, that would go through the actual implementation of the eNeuron toolbox that is the main outcome of this project. The eNeuron idea. So what we were aiming as a final output is for us to develop a tool, an integrated tool for the optimal design and operation of integrated local energy communities that have distributed energy resources and multiple carriers involved at different scales. And we wanted this toolbox to have 4 main characteristics. we wanted not only to account for technical, but also economical and environmental priorities / objectives. We wanted to have the stochastic approach for the operational stages of day ahead and real-time scheduling. And this is important, especially because of the stochasticities that are entailed in this concept of energy communities. We wanted to foster the peer-to-peer energy trading, meaning that for the objectives to be shared, we wanted the community to be able to share energy. And of course, when we are talking about energy communities, there are different actors involved, and we wanted to consider all of them without conflicts. And I'm sure that you are well acquainted with the concept of local energy communities, but I used a small word in the front, integrated. And someone would ask, and what does that mean? And this is a term that stemmed for eNeuron project in order to conceptualize, in order to describe why we are talking about something that is much more than an energy community. Because it is fostering, of course, what is entailed in the directives of the European Commission about what an energy community is, but at the same time, the integrated local energy communities effectively integrate energy carriers, meaning that we can do that with a variety of local generation of electricity, heat, flexibility, flexible demand, energy storage, and electric mobility. We can facilitate cross-sector integration at local level by integrating smart grid and demand-side management technologies with the help of conversion technologies that facilitate this cross-sector integration, and of course, to support the grid by providing ancillary services and flexibility with smart arbitrage coming from the different technologies that cross-cutting the different carriers. And of course, this concept and all the different cross-cutting issues from social, technical, economical, business are resulting to a book coming straight from the eNeuron project, Integrated Local Energy Communities. So this is how an integrated grid local energy community look like. We are having 3 different layers: the prosumer level, the local energy community level, and of course, the regional level. At prosumer level, we are having the building blocks, meaning the buildings or the users, or how we are calling them in our project, micro energy hubs. These micro energy hubs are fostering different type of conversion technologies that are not only connected to the electricity carrier. And you can see that each building block here is having the home energy management system, meaning the optimization algorithm that makes sure that the objective of each individual building block is shared. Then we are having the local energy community level, where all the different building blocks can synergetically collaborate along with community energy generation, community storage, and of course the community management system that is the core, that is the brain of the local energy community. This is where also the peer-to-peer trading is facilitated by exchanging energy for all energy carriers. And at this level, we are having different objectives that could be connected to cost minimization, could be connected to environmental costs, or even connected with grid exchange minimization, meaning that we want self-sufficiency. And of course, at that level, the community as an entity can have energy exchange with the electricity markets, with the upper grid, and so on and so forth. And the main question and the main challenges that our tool is going to answer is how we plan such a system, how we operate, and how we control it. And this is the overview of the eNeuron approach in order to answer these questions. There are certain important characteristics that we defined in order to do so. First of all, we are having 3 layers of functionalities: the planning phase, the operational analysis phase, and the assets control. Each layer is focusing on different stakeholders and needs. So each layer needs to accommodate all stakeholders and have harmony within it. But of course, all layers needs to collaborate, and I'm going to share a small example of how this collaboration is fostered. And we need to make sure when it makes sense when we are talking about energy communities that we are having a hybrid approach. What that means? That means that we are having a bottom-up approach when we are talking about the building blocks. The users, they are having their own objectives, they are having their own needs. And we are having also the top-down approach, because at the local energy community level, there are certain regional or more holistic global objectives that needs, again, to be met. So there are many trade-offs that needs to be taken care of. An example of how the different layers are collaborating is, for example, the following. We are having the planning phase that is connected to the years or the months ahead planning of an energy community, either from scratch or by enhancing, by including some new technologies. Of course, this new design of the system needs to be analyzed in the operational day ahead and the different scenarios in order to see how the operational analysis would affect the planning phase. So what that means in terms of economic and business development. Now, we are proceeding with the eNeuron toolbox concept, having in mind the eNeuron idea and what we want to share. As I was mentioning before, we are having 3 layers of functionalities. And these layers are translated into that. I know that this seems intimidating, but I wanted to leave it as is in order for everyone to understand how complex this is and how challenging this was. And of course, for anyone that is interested, we can share the deliverables and the resources of the project in order to dive deeper, and we are here to answer any question. But please follow me on the certain aspects that I wanted to share, and of course, you can dive deeper in the later phase if you want. First of all, we are having the color coding. This is the blue, and it's the planning phase. This is the red one, and this is the middle layer, the operational analysis phase. And this one is the green, meaning the real time. When we are talking about the hybrid approach, and when I was talking about the top-down, I was referring to that part. And you can see the energy hub level, meaning that these 2 layers are at community level. And the micro energy hub level, meaning that these are the building blocks, and the building blocks can be many of them. So these can be replicated as many times as we are having the building blocks, meaning the users. Now, you can see the 2 main loops that we can have when we are having the collaboration of the layers in order to make sure that we are not having any conflict. First of all, when we are taking care of the optimization of the system design, based, of course, on some inputs that I'm not going to get into details now, you are having a loop here, as I briefly mentioned with my previous example, that needs to go through the operational analysis and to make sure that this design plus the different scenarios that can run in the energy hub, it makes sense in order to share the objectives at the energy hub level, at the energy community level. That could be the cost optimization and, of course, the environmental optimization. And here is the optimization that runs individually in each block. And this we are having different objectives based on the user. And usually we are focusing on cost optimization, but also social comfort. And in order to make sure that the loop is running also between these 2 layers, the red and the green, we are having the peer-to-peer market, the trading that makes sure that this hybrid approach is not conflicting and it's not changing each other. But at the end of the day and the running period, everything is running in harmony. Now I'm going to go quickly through the different layers of functionalities. And of course, Jose, after that, is going to dive deeper on hands-on toolbox, eNeuron toolbox presentation. So the planning phase, as I mentioned briefly, it focuses on years and months ahead. In every layer, we are having main services that, of course, the different target users can use on their own, or they can use in collaboration. I'm going to share an example later about this collaboration of services. But these are the three main services that one can have through this functionality layer. The first is the cost optimal expansion planning for a given structure, meaning that we are having already a design, we're already having an energy community, and we wanted to expand in the best cost optimal way. And then we are having the cost optimal expansion for a new structure, meaning that we want to build from scratch an energy community and we want to see the business case. And last but not least, we are having a trade-off between the cost and the environmental planning for a new structure. Of course, at the planning phase, we are expecting that the distribution system operator, local energy communities manager, energy cooperatives, and local authorities would be using this layer as it is on a global objective, at is the local energy community level. This is the middle layer that is operational phase. And there are two main services that this layer is running at a day-ahead basis. The first is the scenario generation for operational system analysis, and this is also forming the loop with the planning phase. But of course, the cost environmental day-ahead scheduling for different scenarios. And of course, this layer is fostering both deterministic and stochastic approaches. We are still at the local energy community level, and this means that the target users could be the local energy community managers and the energy cooperatives. When I was mentioning about the services, this is an example of how, for example, a local energy community manager can use the different services of the different layers in order to build their own use case. For example, they want to design an expansion of an energy community and they need to design what is the most cost-effective way to proceed, what are the technologies or what are the different carriers that needs to be integrated in order to have an effective and cost-optimal structure, and at the same time, in order to make sure that the operational energy community would be effective as well, they are using also the service number 4 in order to validate their design of the previous layer. Moving forward, and this is the last slide before giving the floor to Jose, this is the lower layer, that is the real-time phase, and it is about controlling the different assets at the building blocks at the user side. We, of course, have the input-output for the real-time operation of the microenergy hubs of the buildings. Let me just remind you that we are having also trade-offs here that are connected with the social comfort, but also with the optimization of the costs. And of course, the monitoring and the participation of the different users in the peer-to-peer energy sharing. Of course, this lower layer, the real time, it is targeting the end users or the aggregators that could play a role in these communities, but also ESCOs and local energy communities for monitoring and see where the different layers are converging with each other in order to have the holistic approach, the hybrid approach of eNeuron. Now, I'm going to give the floor to Jose and guide you through the actual implementation. Thank you.
Hello, good morning, everyone. So my presentation here. Okay. I will present the eNeuron pilots and the assets that are involved in this optimization exercise. Then I will present you the platform. In particular, I will use the Polish pilot environment to demonstrate the assets and the eNeuron toolbox. And at the end of this demonstration, we will provide you a questionnaire so you can also interact and give us your feedback, so we can also take into the considerations at the wrap up of the project. Okay, so in the eNeuron project, we developed 4 pilots in different regions and with different topologies, as we will see. One in Poland, one in Norway, one in Italy, and one in Portugal. The Polish pilot was developed in 8 municipality facilities, including schools, swimming pools, sports facilities, an administration building, and an animal shelter. It covers, in what concerns to assets involved in this pilot, it was addressed, we addressed CHPs, PV systems, solar collectors, heat pumps, one large battery system, and an automatic voltage regulator. We developed 4 use cases in this pilot, 2 on the planning phase and 2 in the real time. So in the planning phase, we investigated what investments in new assets can be done to optimize the capex and to minimize the CO2 emissions. We also produced results in what are the new energy carriers that have higher impact in this pilot in both economic and environmental criteria. In what concerns to real-time use cases, the eNeuron toolbox demonstrated how can we improve the energy efficiency and reduce the energy imported from the grids. And we also experimented the peer-to-peer energy between the microenergy hubs. So in a nutshell, this is the system implemented in the pilots. We have assets, they have their own controlling systems, and they are connected to the eNeuron toolbox. So the eNeuron toolbox ingests data in real time from the assets. The cloud-based solver computes the best usage of energy and provides those outputs to the assets again. This is also ingested by the planning tools in order to use this best usage of energy to better plan the day ahead. So now in the Norwegian pilot was developed in Skagerrak Arena, which is a football stadium, and the community nearby. So it has 42 households and also commercial facilities involved in this pilot. In what concerns to assets, it was we involved the battery energy storage system, the PV system, a large PV system in the stadium covers, and a weather station. The use cases are the same as we did in the Polish pilot. So the planning use cases, so again, looking what are the best assets to better exploit the usage of energy within this community, minimizing capex and optimizing capex and minimizing CO2 emissions, and again investigating what new careers can improve the efficiency in this energy hub. In what concerns to real time, we demonstrated the high reliability of supply, so how this energy hub can also support the grid to to keep the grid securely operated. And this is an overview of the system. So the secondary substations, the PV plant, and the large battery system involved in this pilot. In the Portuguese pilot, so the Portuguese pilot is a military facility, a military naval base in Portugal with several micro energy hubs involved. Each micro energy hub has a lot of assets, PV, solar collector, gas boilers, water tanks, PV systems again, and electrical chargers. And finally, we also have in the Portuguese pilot water pumping stations with the 2 water pumps. The use cases, again, this use case number 1 is common to every pilot. On the real time, we developed the maximization of the local production and the reduction of the imported energy. The EV charging, the green EV charging, so charging when there are more energy produced locally. And again, peer-to-peer energy and flexibility trading between micro energy hubs. This is an overview of the system in the Portuguese pilot. So again, we have the assets communicating to the eNeuron toolbox. Within the eNeuron toolbox, we have all the real-time tools and finally the cloud-based solver computing the best usage of energy in every asset. And we have also the micro energy hub controllers, providing new settings for the EV charger, solar plants, and the battery energy system. And finally, the Italian pilot was developed in the University of March. It covers 5 micro energy hubs, different buildings of the university. And in what concerns to assets, it covers CHP units, photovoltaic systems, hydrogen system, a second life batteries, and 2 EV chargers. The use cases in the Italian pilot, so as I said before, we developed the use case number 1, and on real-time use cases, again, the maximization of local production and usage of that energy, reducing imported energy from the grid, and the minimization of energy costs within this building to building. And this is an overview of the system in the Italian pilot. And now I'll move to the eNeuron toolbox online environments. We have these 4 pilots and online environments. The Portuguese one is not online today because we need to. We did an update last week, and in the Portuguese pilot, we need to go there to do the update. The other 3 pilots are online, and we have this guest email and guest password that will be available until 1 p.m. Then it will be disabled. But until 1 p.m. you can go into and experiment by yourself what I will demonstrate right next. Okay, so this one. Okay. Uh, yeah. It's a PowerPoint to share your screen. Okay. Sorry, the keyboard is different from mine. I had some troubles. Okay, so I hope that people wants to try the system already could enter in one of those websites with the guest user and guest password. I will demonstrate one, and of course, if you have any questions, please put it, and I'll can navigate to other places uh, to respond your questions. So in the landing page, we have the microenergy hubs. In this case, we are navigating into the Polish pilot environment. We can see the assets, and we can navigate into one of those to see what is the historical data. So in this case, we have a PV system in the microenergy hub 1, and we should be able to see the production this morning. So it concerns what is being produced in this PV system. Then we have the eNeuron toolbox in here. So in the eNeuron, we'll have 3 applications: peer-to-peer market, the cloud-based solver with the results of the best usage of energy computed by the real-time tool, and then the asset control. In the peer-to-peer market, so this is the technology tool embedded in deep grid, and here we can see the day-ahead schedule. So we can see the expected prices of energy by tomorrow, and what is being expected to be consumed in this energy hub, the Polish energy hub. On the cloud-based solver, we have the computed usage of energy from the cloud-based solver. So we are publishing here what cloud-based solver decided as to be the best usage of energy. And in the asset control, we will see the same, but with this difference of what users can edit. If we want to have different uses of energy rather than what was computed by the system. So seeing here the bar. Okay. So users can also edit. So the edition is intended to to support the system in new learnings, but also to enable new business models. So if we want to do differently from what was computed by the cloud-based solver, we can access the access control and change the cards in here. So as we can see, this is what cloud-based solver suggested. In the asset control, we can edit a card if we want to change the active power, what is being injected to the grid. We can improve it, or we can make it higher. And by changing the card, it will take different colors. So, and you can see in the icon what was computed by the cloud-based solver and what was edited by the user in here. So these are the new settings sent to the inverter. We can do the same on the bus if we want to change what will be the charging. We can edit it. And at this particular slot, the settings will be different from what cloud-based solver computed. These interactions will be ingested also by the planning tools. So in the day ahead, we can take in this into consideration, microenergy hub by microenergy hub. So in the beginning of the implementation, users will interact more, will define some preferences, and then the system will learn. And in the days ahead, the users will not need to do this interaction because the system will learn and will apply these constraints also in the system. So now we have a questionnaire. I don't know if you have any questions. Yes. How can we? Okay. Now we can.
We'd like if you can use our website because after this we have a user questionnaire. If you can try to use one of these link, the platform, and then we can understand with you if you like our platform. What do you think about the platform? You can use one of these. Yes.
Yes.
Okay.
You can use the three that are online today: the Polish, the Norwegian, and the Italian pilot.
Okay, so you can experience our platform, and we are here for any question. Thank you.
Thank you.
We will give you 10 minutes.
How many?
We have, okay, 10 minutes. Thank you.
Okay, thank you. Yeah.
Okay.
Problems after the link,
Okay.
please let us know.
Okay.
And we are going to help you.
Yeah. Okay. This is
It's working. Okay, we will provide you a couple of minutes more to experiment the environments, and then in 3-4 minutes we will share the questionnaire in the Menti platform. So you'll be able to answer the questions and provide us the feedback we need to close the project. Okay.
Actually, yeah. Yeah, I was just wanted to highlight that you are helping us by giving us feedback. As Jose said, it's the last conclusion of our project, and we would really like to know what you think about it. So we deeply appreciate what you are doing now and give feedback to us. Thank you.
So we have feedback from two people that cannot access the sites. I'm not sure what problems can be, but we tested every online pilots, and I think it is working. So if anyone has any difficulty on accessing, we can try to help you here. I can also tell you that in the asset control application, you cannot edit the next slot. So you can only edit from the next two onwards for securing the system.
Okay. Thank you, everyone here and online, for taking the time to try our platform. So what we want to do now is ask you to fill a questionnaire. So people in the room can scan this QR code. People online, you can also scan the QR code, or you can go to menti.com and add the code here. And now I'm gonna switch so we can ask you a few questions. You can reply real time. This is as Christina was saying, really important questionnaire for us, and it would be really, really important to have your feedback on it. So yeah, please use your phone to scan the QR code, or use your phone to go in menti.com and put the code. Okay. I will wait a few seconds, and then we can switch. Go. Okay. Let me switch to this. Okay. So okay, I see people are already here. So people online, if you have issues, please put them in the chat so we can see how we can assist you. And so keeping in mind the platform that you just experience a little bit, let's reply to this question, okay? So this would be the first question. You should be able to see it on your devices. So please, what is your job position? So you just reply to the question. You want to see the code? Here it is. Okay. People online, I feel, okay. I see 15 replies. Okay. 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 I will go to the other question. What type of organization do you work in? So you can choose between these options. I see we have a lot of researchers and others. Okay, let's go to the other question. Please indicate your level of agreement with the following statement. So again, keeping in mind the platform that you tried, that Jose showed. So you should see a bar and you can just move the bar from extremely disagree or extremely agree for this statement. So the first one is using the interface, that the microenergy hub interface that we just showed in my job would enable me to accomplish tasks more quickly than with other similar platforms. Or using the ME interface would improve my job performance, or using it would increase my productivity, or would enhance my effectiveness, or would make it easier to do my job, or would be useful in my job. Okay, I see. You mostly agree. That's good. That's nice. So I will just give you a little bit more time. I see 18 people replied. Okay. So in general, it would be useful. That's nice. Make it easier. Okay. Let's go to the next question. Please indicate your level of agreement with the following statement. So as before, you need to choose if you agree or disagree. So learning to operate the interface that we showed is easy. or I found it easy to get this interface to do what I want to do, or my interaction with the interface was clear and understandable. I found the interface to be flexible to interact with. It was easy for me to become skillful at using the interface, and I found the interface easy to use. So of course that helped us in the design of the interface. I will give again a few minutes just because I see that people are replying, and then we go on with the question. Okay, let's go on. How much do you agree with the following statement? I have the resources or I have the knowledge necessary to use the interface. Okay. Okay. I see you think you have the knowledge. Nice. Okay. Everyone replied pretty quickly on this one. Let's go on. Now the statement is, I feel confident using the interface without assistance. So that evaluates the computer's self-efficacy. So again, you have to see to say how much you agree. Okay. You agree pretty much. That's good. Let's go to the other one. How useful would the eNeuron toolbox be for your organization in achieving its goals? So you have to say from not useful to very useful, how much would it be in eNeuron toolbox? Okay, pretty useful. That's nice. Okay. Let's go to the other question. We are almost done. How much do you think the eNeuron toolbox introduces a technological advancement compared to the other state-of-the-art solution? So when it comes to the level of facilitation, from not at all to very much, you can indicate how much do you think introduce a technological advancement. And I can see still very much. That's nice. Okay, next question. How likely you would recommend the eNeuron toolbox to other organization? So to not at all to very likely. Okay. I can see. Very likely. That's nice. Okay. I think everyone replied. So that's it. So thank you everyone for this. Now we are going to the next part of the event. Let me give you, where is it? Voilà. Okay. Okay, I invite now. All right, now it's the round table. I invite the moderator, that it's gonna be Venizelos, and the speakers. Now Venizelos is gonna be the moderator. I will introduce you the three speakers that we have on site and the one that we have online. Okay, so I give the floor to them. As always, people online, if you have comments or questions, put them in the chat or raise your hand. Okay, thank you.
Well, good morning from my side as well. I think it's been an interesting morning. We have heard a lot about eNeuron and how eNeuron has addressed the technological evolution of systems in support of energy communities. And, we have high hopes for the catalyst effect that energy communities can have in the energy transition process. And that is why for us it's very important that this obvious operational contribution of energy communities can be served with the technology solutions that we have seen today. And I'm sure that what we have heard earlier from Maria Valendi, from Cristina, and from Jose, that issues related to technology evolution is something that is well addressed today. We have seen the results, we have played with them, we have responded positively about them, and it seems that we are getting also from the pilot cases that eNeuron had, we have received positive feedback as to how they can see the outcome of the project, positively supporting their work out there. And that is very, very encouraging to see. And of course, we know that in this energy transition process is not only technology that matters, and I'm sure technology, we all agree, that has advanced quite faster than policy and regulation. And here, I think, today, we need to address that as well, because technologies is not the only need. We need to have the policy drive and the regulatory enabling in order to be positive in what we are trying to do. And of course, we have today our expert team here. We see Mara Laura from the distance. Good morning. And we also have Sergio Olivero, who is with us here. Welcome. We have Selene Leverani, welcome. And we have also Magnus Askeland, who is a partner in the project, but today he's going to talk to us a bit the relation issues with other projects. And I think here we have and we want to see through these to answer the important question of what's the future of energy communities? How can we really see them being developed, functioning, and delivering? And in that respect, we can invite our colleague Sergio Olivero, which is the head of business and financial innovation, Energy Center of Turin Polytechnico, to present to us as an introductory information from where he comes and what is his contribution to energy communities. The work that they are doing on the Percerto project in Italy, who are putting a lot of effort in delivering to the Italian communities a very positive response to what they can achieve as communities. So, Sergio, please. You have a few minutes to tell us about it. Okay. And we definitely would like to see later on to see how what we have heard today is really contributing to what you're trying to do through the projects.
Okay, thank you very much. I will try to be as quick as possible. I just have to, okay, it works. So what is the future of energy communities? First of all, what is an energy community according to the European RED II directive? It is a legal entity made up by producers, users, and prosumers. The focus is on the legal entity. It is a company, practically speaking. It is no profit company, but it is capable of being the catalyst of innovation at technological, but also governance level. You must be aware that the Italian government has already transposed the European RED II directives with a law that was issued in November 21, and it is now completely operational. That is, you can create energy communities, and there are relevant incentives, roughly 100, more than 100 euro per megawatt hour of shared energy, which is the principle. The principle in Italy is the so-called virtual sharing. In this example, you can see a prosumer that has a photovoltaic system generating 100 megawatt hour. Let's assume that 10 megawatt hour are 10 kilowatt hour are self-consumed, then 90 kilowatt hour are sent to the grid. 90 kilowatt hour are sent to the grid, and if we assume that two consumers get 75 kilowatt hour, in this case, the virtually shared energy is 75 kilowatt hour. It is the minimum between the two values. And you have you get an incentives, roughly 100 euro per megawatt hour. That is, 1 megawatt of installed power generates from 100 to 130,000 euro per year for 20 years. This is a lot of money. Practically, this is the top of the iceberg. That is the RED II directive, incentives on shared energy. But there's also another European directive, the 944 on the energy market, that is related to immobility, to trading, ancillary services, flexibility. That is the majority of the value generated is not just the incentives on energy sharing. There are a lot of additional services, but we have to be aware that in Italy, the incentives themselves are enough to make the investment capable of being of interest for large investors. And if we add all the other incomes related to the services, we must be aware that important business models can be designed. This means that since a renewable energy community is a company, the main issue is not technology. Technology is a necessary condition. We have to think of organization and of governance mechanisms, especially capable of making renewable energy community stay together. This means that there's room for clustering the RECs. Clearly, we need ICT platform with artificial intelligence capacity. And this is the concept of the C-RECs, or cluster of RECs. This means that in Italy today, many RECs and C-RECs are growing, and making energy communities work together practically creates a virtual energy company. This is not philosophy. This is currently being achieved by the so-called ConcertNet network. There is in Magliano Alpi, the first Italian renewable energy community in 2020, and Percerto, that is an Italian-wide REC founded in October 24. The meaning is that clustering renewable energy communities create a virtual energy company that is capable of getting a large part of the added value related to the transposition of the two European directives. So the point is that technology, yes, governance, and then the capacity of being attractive for investors. There's a lot of money. In Italy, if you install a photovoltaic system of 1 megawatt and within renewable energy communities, under good balancement condition, you have a break-even of 4 years of a 20 years incentivation time. That is really attractive for investors. So money is the leverage to use in order to make energy community work. And in Italy, we have the legal condition to do so. Well, this is the ETIPS Working Group 5 that has a specific action focused on energy communities.
eTipsNet, as you know, is a technology platform, is aiming and bringing together the experts around all energy transition issues, and is doing a lot together with Sergio on this issue, and we are trying to put forward a good practice approach for other countries to follow. So thank you very much. And I think now we will have Mara Laura Di Soma that is going to talk to us about her background as being one of the contributors to eNeuron, but now also as an academic person of how can we see the results of eNeuron and helping the academic efforts around this energy transition process. Your floor is yours, Mara Laura.
Good morning, everybody. I hope you can hear me and you can also see my screen. Can you please confirm?
Yes.
Okay,
yes,
thank you.
Good, yes.
Okay, great. So first of all, I would like to thank the eNeuron coordinators and Venizelos for inviting me to the final event of the eNeuron project. I'm really honored today to be here for this roundtable discussion and also for being present to this final event, to have the evidence of the final results of the eNeuron project that I've seen being born and I've followed in the last 4 years. So when I prepared my slides to support my discussion today, I needed to find a title, and I thought about eNeuron Excellence, because I think eNeuron has been a really ambitious project since the very beginning, from the innovative concept of integrated local energy community to the innovation behind the eNeuron toolbox that addresses all stages from planning, operating, and controlling energy communities with multiple energy carriers beyond the electrical one. So my intention today is really to, is really to make evidence of the achievements through the research work of eNeuron project in developing the required tools and solutions going beyond the state of the art, aiming operational excellence, higher efficiency, and easy use by end users. Let's start from, let's say, the integrated vision that was the cornerstone of the eNeuron project. So as we know, the electrification is considered a cost-effective pathway for decarbonization of final energy consumption. But a strong electrified future poses important questions for the power system. For example, how much additional power network capacity do we need to satisfy all types of energy demands? Or what happens in case there is a contingency in the power system? On the other hand, if let's say, if electrification of final consumption is combined with the integration of energy sectors, decarbonization of energy demand will be reached through penetration of renewables in all energy and user sectors, while also getting higher flexibility for the whole system. In fact, in this integrated energy system, multiple energy technologies can be managed with high synergy to satisfy the multi-energy demand, and services can be provided with the most convenient energy carrier and sector. Well, the eNeuron vision is well related to this last innovative concept, namely an integrated grid approach through integrated local energy communities. ILEX combine the concept of the integrated grid at the local level with one of the energy communities, and so represent an efficient, sustainable way of managing energy at a local level by also fostering consumer engagement and empowerment. However, as we can see, actually, when thinking about an ILEC, actually there are a lot of challenges. For example, we need to take into account the interaction, the complex interaction among energy carriers. There is increased uncertainty and variability related also to renewable energy sources and demands, collecting stakeholders' interest and interaction with the market. So eNeuron has a solution for all these, let's say, challenges, and let's say provides a reply to the main questions when thinking about an ILEC. So how we plan an ILEC, how we operate an ILEC, how we control an ILEC. Well, the eNeuron excellence is intrinsically related to its toolbox that is unique and let's say has a unique value beyond the state of the art in the fact that addresses planning, operational and control aspects all together. And the most important thing, that is flexible in adaptation to real context by also using separated tools according to the specific scope and goal of the user. In the planning phase, it allows for, let's say, designing an ILEC from the scratch, and also for, let's say, plan the expansion of an ILEC. For the operational analysis phase, it allows for the day-ahead scheduling of technologies in the ILEC, but also for stochastic, let's say, operational analysis and forecasting issues. Whereas for assets, let's say, control, it allows for real-time optimization of flexible assets, monitoring of data, and so on. So last but not least, and here comes the important role of research academia in achieving improved performance in all the respects, is the high modularity and flexibility of this toolbox, because it is mainly related to the mathematical programming approach behind it, on which the toolbox is based, and of course the multi-objective approach that is used in all the levels of the eNeuron toolbox and allows to take into account both economic and sustainability priorities, as for example, carbon emission, energy efficiency, renewable energy systems integration, and so on. Thank you for your attention.
Thank you very much, Mara Laura, for this, and stay on with us. We have to discuss further this issue and see how we all agree the way forward. So we have with us Selene Leverani, who is coming from ETSO, the association in Brussels, representing DSOs, and we would like to hear from her how she sees, or how ETSO sees the, let's say, the facilitating responsibility of having energy communities operating their assets, their developed assets, shall we say, in order to be contributing positively to the wider energy system as a whole. So how do ETSO see this collaboration with energy communities?
Thanks a lot, Venizelos. I'll go with my presentation. Sorry. Okay, here we are. Thank you very much again for having me here today. I'll just say a quick couple of words about who I represent today before moving to the content part. So European Distribution System Operators, or EDSO, is a Brussels-based association of big-sized and medium-sized system operators that distribute electricity in at least one European country. We represent 36 members in 18 member states that cooperate within the association to facilitate the energy transition according or around some fundamental pillars, which are decarbonization, electrification, digitalization, and of course, customer empowerment. Our work of the association revolves around these three main umbrella areas: policy and regulation, technology, and innovation and research. And needless to say, the topic of active customer participation and empowerment in the energy system is very transversal to all of these areas. We can see it in the work of our customer empowerment working group that is looking at how transposition of European regulation according to different national models is supporting active engagement of customers. We see it in our European-funded projects. But we also see it when we perform research and the best experience exchange among our members into how, for example, optimize local energy management or how to accelerate the renewables integration into distribution grids. So this is no new information for you, I'm sure, but since the Clean Energy for All Europeans package got published, there are several provisions at European levels were introduced to facilitate the establishment of energy communities and create a benefit for the community members, but for the overall energy system through a series of activities, generation, consuming, sharing electricity, and provision of flexibility service to the energy system. For the DSO, this introduced some great opportunities. The first, of course, to enable this customer empowerment and lower entry barriers or offer the possibility for new market players to enter and participate in the power system. But also to enhance the resilience of the electricity network and facilitate local load balancing. And third, optimize all the connection processes for renewables and electrified load to the electricity grid and optimize allocation of network investment. Unlocking these opportunities, though, leveraging on this opportunity comes with the need to fulfill some needs and associated challenges. Yeah, if we look at the setup, of course, there's a need and an intention to agree on clear roles and responsibilities between system operators and energy communities, which can be supported by a certain level of harmonization and in the introduction of frameworks that can support performing certain activities, such as energy sharing. We discussed planning many times today and working together and cooperating and implementing new solutions to facilitate connection, especially in those areas where there are some grid capacity limitation is also a fundamental part. In terms of operation, communication and information exchange needs to be streamlined between DSOs and energy communities, starting from the contractual agreements and the setup and, in fact, into operation when it comes to metering and consumption data. And, of course, grid-friendly behavior should be incentivized because in itself performing some of the activities we have mentioned does not facilitate grid management and operations. So this type of exchange is also fundamental. For all of this to happen, there needs to be a regulatory framework, also at national level, that supports the role of DSOs as facilitators of energy communities. And this should be kept in mind, of course, for the establishment of network tariffs that are cost reflectives and take into account all the developments that need to take place. And so as neutral facilitators of the energy transition and of the role that energy communities can take in the energy system, DSOs are driving and participating in several initiatives at European national level. I'm here mentioning a few that is going to be food for thought, I think, for the rest of the panel, starting from, as we said, again, planning in coordination with the local authorities and communities, the testing and implementation of energy applications and platforms for streamlined communication and to support informed decision-making from community managers and community members. But also from a wider perspective, looking at regulatory proposals and new business models that can facilitate active participation in the provision of flexibility services. And this is it from me. Thank you very much.
The words coming from the representative of DSOs is strongly supporting what energy communities expect in this process. And I think we have heard, the local balancing that Selena has indicated, and also the grid management requirements that are central in this process and how DSOs can facilitate this process forward, I think as keywords and key activities that are in full compliance with what is expected from DSOs. And thank you very much for that, for energy communities to be flourishing forward and being a contributor, an active contributor to the energy transition process. And I think this is fundamentally true. So other projects, eNeuron is not alone in this evolution of technologies and way forward. We have with us Magnus Askeland, who is going to talk to us a bit about the project FINE that is highly related with what we're doing in eNeuron and how this is complementing. Yes, Marcus.
Yeah, thank you. And thanks for the opportunity to be here and talk about the Norwegian FINE project, which is led by Center for Energy Research in Norway. It's a national so-called knowledge building project that has been going on at the same time, parallel to the eNeuron project. It just ended last year and has been, I think it started in the same year as eNeuron as well. So in addition to working on eNeuron, I've been also working on this project, and it's highly related, even though the FINE project mainly focused on the electricity grid integration of energy communities. So what I will talk about now is not the whole project, because that we don't have time for, but I will talk about a specific result from the project that is, I think, is highly relevant for the eNeuron project and what we're discussing here today. So one important thing in this project was to structure innovations and also literature and also initiatives regarding energy communities. And to do that, we've came up with two main dimensions, as you can see here, vertical and horizontal. So the first dimension, the vertical one, is how active is the DSO in the system? Is it a traditional so-called DNO, which mainly is not doing anything during the operational phase? It's just building the grid, making sure that there is enough capacity. And this is transforming to active DSO, which is also considering operational measures to maintain the balance in its grid, that's one development. And you have the second development on the horizontal axis, which is going from the centralized top-down approach in the system planning and operation to a more decentralized bottom-up approach, which you can think about energy communities is one example of that. So this is these main two dimensions that this project came up with to discuss the innovations that we're talking about today. So within this framework, we came up with 4 scenarios for development, strategic pathways, you could say. So today we are, at least in many parts of Europe, we are in the so-called reference scenario, where each individual consumer is doing what is best for themselves, optimizing, for example, a single building or something like that. Not really coordinating with other consumers on a local level. While these other scenarios represent different development pathways that are in some current countries ongoing and in other countries not there yet. So if we go to the right, you have this cooperative scenario, which is basically still with a traditional DNO, not doing anything very active, but letting a community coordinate internally and optimizing energy flows locally. For example, the DSO may be interested in is community lowering its total capacity, and that's the only thing that the DSO needs to consider, is to give them an incentive to keep the total capacity at a certain level, and then community will do the rest. if we only go upwards to the competitive scenario, we have a more active DSO and still a top-down approach in the system control and system planning, which basically means that the DSO will be more active in contracting capacity at individual consumers and basically incentivizing or controlling assets at a local level to obtain grid level goals, but still no decentralized interaction between consumers. So if you combine these two developments, we go to this so-called participatory scenario, which combines both elements. So you could think about having energy communities optimizing internally and still have a mechanism where the DSO can exert influence on that operation as well, to coordinate maybe among several energy communities, or maybe among energy communities and people that are not part of energy communities. So this is just a short introduction to the framework. If you want to read more about it, we have written an article about this specific strategic pathways, which is currently under review in Energy Strategy Reviews. But we have published a preprint that is not peer-reviewed yet, but it's available for those that are interested, and you can see the reference here. Yeah, thank you.
Thank you very much, Magnus, for this correlation with other projects and how you have introduced here important, let's say, operational possibilities of how energy communities can evolve into going future. And I think some interesting words we have heard there, like participatory, cooperative, and I wonder what is the reaction of DSOs on that. But I would like to continue now after this initial introduction from our experts on the panels to be more interactive, more participatory with you. And so please feel free to raise your hand to pose a question. And this is also an invitation to the people connected virtually to do that also. And Chiara is here following you closely. And if you raise your hand, we will give you the floor to ask a question. But what is your initial reaction to what you just heard as coming as possible cooperation between energy communities and DSOs?
Yeah, first of all, very interesting research, and I was looking before today at the matrix presented by Magnus. I think it's clear to us that we are moving vertically on that matrix in the sense that DSOs need to take and are already taking a much more active role in the energy system. And this is not just in relation with energy communities, but of course, if we want to make sure that we can integrate electrified mobility, for example, or electrification of heating, and increasingly integrate renewables, this is something that needs to happen. Grid reinforcement is and will remain necessary, but the optimal way to ensure that this happens at the system level is to leverage also on all the sources of flexibility that are offered by the stakeholders, including the energy communities. Looking at the other side, let's say, or the horizontal line of the matrix, this is also quite interesting. Here is an area that I think will require further exploration in a sense, and I see both models possibly affirming in different contexts that will depend on national characteristics, regulatory frameworks, and we see both the more market-based approach on one hand and other type of engagement and flexibility provision being tested and researched at the European level. So from this point of view, I think very important cooperation, of course, and research are two important areas to tackle.
Mm-hmm. Thank you, Selena. Yeah, we have a question. Yeah, okay. Haji Ahmed?
Yes.
Okay, go ahead with your question and who you are addressing it to, okay?
And I have a question, what are the opportunity for implementing multiple energy system with optimization with the help of AI, deep reinforcement learning? Like I am currently working with master thesis.
Yeah, can you clarify a bit more the question you are asking, or beyond your statement?
Yes, she say, we have to integrate a system with optimal electrifying things. I want to ask how we can implement energy system multiple energy system for electricity, heat, and maybe for hydrogen system with AI, to get optimal result from these technology, these sectors.
Okay.
Which
So
AI model are suitable for optimizing these sectors?
obviously, eNeuron has addressed it from a multi-vector approach. Now, to what degree AI can be introduced as a supportive mechanism or a supportive intelligence to what we want to do? Who would like to respond to that? It can be either from the panelists, can be anyone. Yeah, please, Maria. Yeah, take a.
I think that artificial intelligence can help at two levels. The first one is for all the activity connected to the forecasting. For example, we can use for the forecasting activities artificial intelligence. And also we have experienced, I said in the initial part of the AI, we have experienced this problem of the lack of data. And the new models based on artificial intelligence can work on this aspect. We can implement some forecasting models that use a lower number of data for forecasting models. And this is the first level. At the second level, we can improve the final part, the final user use of the toolbox, for example, by using a chat box or some instruments that are artificial intelligence based that can help the user to use the platform. Today, we have experienced the use of the platform. I think that we can improve this part. This wasn't a goal of our project, so we didn't work on this part, but I think that we can improve this part. And so I think that artificial intelligence can be very important for the future of energy communities.
Yeah, thank you very much, Maria. And this reminds me of the webinar that eTipsNet is putting forward for how AI can play a role in the grids of tomorrow and how AI can be supportive on all of these processes. And this is going to be, I don't remember the date and time, but please, you are going to see it in your mail, and please connect to it. It's a very interesting paper we are putting together, and connect, because it's going to be a webinar, it's going to be discussion, it's going to be, you can put your questions forward, and please connect. Oh, yeah, who? Okay. We have heard quite a lot about what eNeuron has achieved through the technology evolution and things. And you are doing a lot in Sergio on the energy community side, from I would say from the organizational side, from the regulatory side, from the policy side. To what degree you see these technologies playing a useful, positive contribution to what energy communities are doing? Because we have heard quite a number of questions before asking us how it makes it easier, how it makes it facilitating the process, to what degree you see these technology solutions helping energy communities?
I think energy communities can play a double, energy technologies can play a double role. One is the role of energy technologies for the sake of making energy communities work well. We can clearly improve the performances. We can streamline the processes. On the other side, we have the opportunity of using technologies in order to enhance the business plans, business models and business plans related to energy communities. That is, implement governance mechanisms that integrate also other issues. For example, the financial issue is especially those related to carbon credits, those related to really green economy, so not greenwashing, but serious green approaches. An energy community is, at the end, a database, a data repository that can be used in order to certify processes. So energy communities can become the engine where new approaches of data management are prepared and certified for the financial community. In my opinion, there's room for, how can I say, not just developing technology, but starting from the status today where a lot of money, really a lot of money is available. Many investors are just asking to spend their money, to invest their money. So they need not just something that works, a technology that works. They need a system that is reliable, whose level of risk is can be defined. An energy community can be seen as an organization and governance entity that play the role of making the wheel roll and then at the same time improving the quality of life of people. So putting citizens and people at the center of energy transition, like the Clean Energy Package of the European Commission says, but at the same time a tool to streamline the allocation of investments.
Thank you, Sergio, for that. And how do you react to that, Jose? You're a provider of technology, and they have a lot of money there. How do you react? But there are a lot of money out there being spent in the direction of making energy communities more effective, more user-friendly, more productive in what they are trying to do.
Thank you. Well, I see the energy communities are being, let's say, as an institution, are quite different from the grid owners, the grid managers, the DSOs or other energy carriers grid operators. And well, I see the communities, they have an objective of investing in assets and optimize the community by itself. And the objectives from the grid operators are, well, are very different because they are operating a critical infrastructure, a country-sized infrastructure in the most of the cases. So the constraints are very different. The business are very different. And I'm not sure if we have the frameworks to interoperate both. I mean, how can a community interact in the best way possible to the grid, and how the grid can use the flexibility from the community? And I would like to know from all of you, how are you seeing this evolving, if there will be market operators to exchange energy in hours ahead, or because as far as I see today, we just have interactions for seasons ahead, not hours ahead. And yeah, I see it's very complex to integrate a community in a very complex system as it is a grid. So
Yeah, of course, you can reply, but
I hope that the further investments would be in these integration partners, integration companies, markets, and so on.
Yeah, but I will give to Sergio in a minute. But we have heard Selena before saying that we aim for local balancing. We aim to serve local balancing through the actual effective use of energy communities, providing flexibility, resources in an effective way. So I'm sure today DSOs are not mature in this sort of evolution of the market, but they are willing to do it. So let's work in that direction. And I'm sure there are answers out there that we can. And because it's a wish, that's what Selena said, I think we will do it. It's a question of providing the platforms that can communicate, cooperate, and contribute to whatever is required. Local balancing is a must if we are going to achieve zero emissions effectively and efficiently. And I'm sure we are going to move in that direction personally, and we are going to see it. Yes, Sergio.
Really quick. First of all, we should organize a one-day workshop in order to discuss this issue. But I just make one. In Italy, there's one of the main DSO in Italy, this Enel Distribuzione. Last year launched the EDGE project on the creation of BSP, Balance Service Provider. And we use the Percerto Energy Community as BSP. So the energy community has started operating as a BSP. In this case, not doing the energy community, not sharing energy, but doing what the energy directive says, a renewable energy community can provide balancing services, can trade energy and so on. So this is an example. So energy community is a legal entity, is capable of doing many things, and it is the differential with respect to the basic concept of energy community that can make the difference in helping DSO and TSO at achieving the local balancing needs.
Yeah. We have Haji Ahmed wanting to say a few words on that. Is it a question or a statement? Please go ahead, Haji.
Like I want to comment on it, like how can maybe transfer from like we have like in Italy I have a study like 3 courses on power generation and distribution. Like now, like in USA, like I have read some review paper. Now in USA they are trying to like implementing microgrids and with respect to like main grid. For local demand, they are trying to implement microgrid with multiple energy, like sustainable multiple energy, like when solar, maybe they are trying to like if they have excess power, they are converting excess energy into the hydrogen, ammonia for like generators, for backups. Like they are working on microgrids and they are improving technology towards microgrid. Before they are working on like a whole main grids, but now that things are changing and make more efficient to work on microgrids. Maybe there is opportunity for microgrids to meet local demand, like local demand for small industries, small businesses, and building sectors. For main grid, there will be like more demand for industrial sectors. For local, maybe it will be good to improving microgrid with sustainable technologies like renewable. And as already said, if we have more, if we have forecasting data, where is the more wind and solar, we can implement microgrid and get benefit from that area and maybe put some industry there because renewable is not everywhere and we get like from forecasting data we can get opportunity to that particular area and maybe implement some microgrid there. That's my idea.
Thank you, Haji, for that.
Thank you.
I see Maria Laura agreeing in certain comments, but we would like to hear also this evolution of, let's say, the energy communities and how the legislation and codes, they are being transformed at national level. But we don't see fast evolution into the actual systems. Why you think, Maria Laura, how can the academia can help in that direction? Do you think,
Yes.
do you see a role in that, or what?
Yeah. So I think this is a very good question. That's true that the policy and regulations now are fully supporting energy communities, right? So as also highlighted by Sergio this morning, starting with the clean energy package that defined for the first time the concept of renewable energy community, of citizen energy community. And this is going also to be implemented at the member states level. For example, Italy, that among others is creating a really, let's say, friendly environment for energy communities. But yes, I'm totally aligned that there is still, let's say, a slow process that sees, let's say, a slow grow up of energy communities at member states. What is the problem? First of all, I think that the main problem is really related to end user involvement, let's say, in this innovative concept of, democratic management of energy. So I think that it's still hard, really involving citizens in the energy transition, and energy literacy is the key, in my opinion. Regarding technical issues, I think that business models related to energy communities are still limited. And developing new ones may also require, let's say, energy management and IT tools that optimize the operation of energy communities. eNeuron has, let's say, made a lot in this sense by also proposing new use cases and business models for creating, let's say, value for the customers. But of course, I'm now talking more about renewable energy communities. I think that business models, let's say, more business models should be, let's say, created for really fostering the deployment of energy communities. Another technical gap, I think we have already discussed this, is the absence of a proper market architecture and design, which enable the massive prosumer involvement. We know that in energy communities, there is a large number of players. And so actually, there is also an unsecured data flows, and the future energy markets need to address all these physical congestion. So from the academic point of view, I can say that a promising research line could be the development of novel market pricing schemes, which consider the network and other technical congestion based on network parameters at the point of common coupling.
Mm-hmm. Thank you very much. Yes, Christina, you want to react to that?
Yes, I wanted to integrate on Maria Laura's statement that I am fully aligned with, of course. And I wanted to reflect on the concept of microgrids that has been mentioned. Because Maria Laura mentioned already that it's not only about the technical aspects. Sergio also mentioned it's not about the technologies, it's not about the architecture or the concepts that we are employing as technical people. It is about the business model, it's about the governance, it's about the market design, as Maria Laura mentioned, and Sergio as well. So I wanted to highlight that microgrid is a promising concept. It has been included and introduced firstly 10 years ago. Web of cells is also something as promising as microgrids. Energy hubs is also another architecture that we employed in eNeuron. So it's not one solution fit for all. And as technical people, we can be really creative with promoting technical solutions. But the main challenge here is how we are making this possible with having sustainable business models, with having a governance that fits the purpose, with having people being engaged. So I wanted just to make this comment in order to realize that it's not about a technical concept that needs to be the forerunner. We need to be creative, based also on the specificities of the different pilots of the different countries, and focus on aspects that needs to be resolved. Thank you.
Yes, thank you very much, Christina, for this intervention. We have interventions from the floor. Please go ahead. But before we give the floor, Selina, how do you react to that? Because I think their DSOs, let's say, are considered also a bit slow in picking up this evolution of technologies. And how can they make effective, let's say, the required flexibility market? What is missing? Why we are not seeing it?
Yeah, so adding up, maybe I'm commenting on what Maria Laura said on the side on end user involvement and energy literacy. Yeah, we know this is not an easy scenario to navigate, and I think in this room we are not the most representative for the whole European population. I'd like to highlight here an initiative we are being part of, quite important at European level. Through the Eclipse project, we are working on developing a common European framework for energy saving applications. So bringing together requirements, needs to develop interoperable architectures for applications that will allow users to make informed decision making, understand really their energy consumption and how this can be changed for their own benefit, which could be economic, but also non-economic. And I think here we see in energy communities really the drivers to participate and engage in these activities as first adopters as well. But at the same time, very importantly, incentivize communication with the grid operators and grid-friendly behavior. As I mentioned before, in itself, participate or generating energy or trading energy doesn't mean supporting the grid. And to make sure that there is mutual benefit from this solution, or the Eclipse work is gonna put a significant milestone in the work there. Looking at other ways and again, different models that could be established. I think the example of local flexibility market and, for example, the EDGE initiative in Italy is a great example. There's other ways. The market models are, let's say, for flexibility services for distribution grids are still at an early stage and are relevant in some contexts. In others, different models or different ways to procure flexibility could emerge. One example that I would like to make, for example, when I mentioned before connecting to grids. This, especially in some European contexts, in some grid is becoming increasingly complex due to the changes that are taking place as part of the energy transition. Local load balancing that we mentioned before here is going to be very fundamental. So the way energy communities could or the cooperation with energy communities could relieve this problem is quite important through the aggregation of their demand and generation, and maybe combination with other tools such as non-firm connection agreements could be a great way also to tackle the problem.
Thank you, Selena, for that. And I think you are putting forward also that we need to see an evolution of the market as well. And it's essential if we are going to see all these going in the direction that we will generate the possibilities of achieving local balancing or utilizing efficiently and effectively the flexibility market. Yes, Magnus, you wanted to intervene, and then we will go to the floor. Yeah.
Yeah, it's very interesting what has been said, and I can add a bit to also what Selena's mentioning. And I think to see deployment and to get this ball rolling regarding energy communities by itself, outside of academia, outside of research, it's important to have value creation, which can also be in the form of reduced costs. And this is what we're seeing in Norway now. When we talked to grid companies 5 to 10 years ago, they were not so interested in measures in the operational phase. They were mainly interested in reinforcing the grid to solve the issues. But today, the situation is completely different. They are very interested in both energy communities and other things that can resolve issues right now. And the main reason for that is that we have, in Norway at least, a very rapid electrification of things that have previously not been electrified are getting electrified quickly, and a new production coming in, decentralized in the system. So now they're looking to new solutions because they cannot build grids fast enough, and also they don't really know where to build it because they have long lead times. So it's hard to predict into the future. And you also mentioned the non-firm agreements as an option. This is also something that we have explored in this FINE project, but we have seen on a variant of it called coordinated non-firm agreements, in basically where you have an energy community and you have a new entrant into the community which has a non-firm agreement, but this new entrant may not be flexible, so it may not do anything about the situation. But what we did there is to coordinate inside the energy community so that this new entrant can procure flexibility in the energy community from someone else, resolving the issue and avoid being disconnected. So this is one example of a connection between the DSO needs and what energy communities can deliver. So I think relieving local grid congestions, maybe not indefinitely, but for a few years, that I think there can be a lot of value created or cost saved there.
Good. A lot of good thought there, food for thought. Yeah, please. Is it a question or an intervention?
No, it's both. It's a small statement. No, it's not a statement.
Okay, please go ahead.
My name is Alex Hadzibiros. I work at the Samsø Energy Academy in Denmark. Samsø is a carbon neutral island. I was done in a participatory and local ownership approach. And we're part of the Clean Energy for EU Island Secretariat, also supporting 30 islands in decarbonizing. Part of our work has been on grids. And there's a big event coming next week on the 30th about how to decarbonize island grids. And during the last years, we've seen a lot of problems of how to integrate renewables. And of course, the energy communities is a new big thing. And from our experience and our work, the DSOs are not extremely happy about it, at least not in every case. In many cases, they have been resisting or lobbying against, or it's the biggest, enemy of small energy communities that want to connect, which is, of course, a new paradigm. And there's always, resistance to change. This is clearly the future. But there is a lot of, work. Selena, you mentioned energy literacy. There should be some also energy communities literacy that should be increased. So if I take the example of the axis of the poll, how do you agree, extremely disagree, or extremely agree on how good or how a good approach is energy communities, these DSOs would probably be at the moment, I would say, at least for the case of islands, towards the negative part, because it's kind of disturbing or disrupting the business model in many cases. But so it's again, there's a lot of room for moving upwards to the scheme that Magnus showed. So the question is related to the, long introduction, is about if you have, we would really like to see and work with examples of DSOs that have this more forward-looking approach and are actually going to talk to, I think there was an example of in Ireland, they called it like a roadshow or something a few years ago. I'm not sure if I'm right. But if there are DSOs, and maybe not in Norway, which is maybe more advanced, but even in other countries that understand that this will be the future and they could see a few decades ahead and not focusing being too much attached to the old business model. And whether this dialogue with other stakeholders, communities, or because it's at the end of the day, it's the benefit of everybody for the future. Is being done or is being, I don't know, designed or thought of. So what would be the DSO's approach if you have an insight or some good examples about that? Thank you.
Thank you very much for that. And I think we are proving right, Sergio, that we need a day to discuss all this. And certainly there is a lot of discussion that we need to do. And I'm sure that there is a lot of positiveness coming out of the DSOs. I'm not going to defend them because I was a DSO at some time, but I'm sure that they would like to see this evolution coming forward. But as you said, it's difficult times we are. Things are changing, maybe faster than what they would expect. But I'm sure that eventually there is going to be a very positive reaction coming from the DSOs as well. And it's a question of us bringing the correct technologies, the correct solutions, and also addressing correctly the market evolution and policy evolution of the countries. Because sometimes they are reacting like this because the regulator is demanding certain behavior and they are not giving them incentives. And I know that. And that is why we would like to see from the regulators incentivized approach towards the evolution of technologies and evolution of market and otherwise. So all these are a need and a requirement. It's a question now of adapting to it. There is another question. Yeah, please, go ahead.
Hello, I'm Dimitrios Lagos from MIREC, the Institute of Research Energy of Catalonia, Barcelona. And I would like to raise a question with respect to what you said, Sergio, before. Because you said that the economic incentives exist to form and invest in local energy communities. But we see that the user, I think that somebody else has said it as well, that the user engagement is not to, like people do not form a lot of energy communities. Of course, there are more than in the past, but still we're in the process. And as I understand, a nice green energy transition would be with a lot of energy communities, and it would be sustainable from an environmental point of view and a societal point of view. So my question would be like how we could facilitate the formation of energy communities of the citizens, so that the citizens come together and formulate local energy communities. Because I heard that you said also that there are like more private investors that want to invest in energy communities, and that there is economical incentive. So, I mean, the question would be like how we could facilitate bringing together people in order to tell them, okay, there is an economic incentive that you could benefit by taking initiative and forming an energy community that would be benefit for all, like for you, your local society, and the environment.
Well, we have to be aware that energy communities are both a business opportunity and a part of the green ideology. Maybe in Northern Europe, you can convince people to enter an energy community saying you are greener, you save CO2. I can assure you that in Italy, you say to a citizen, you will save CO2, and the answer will be, but my own benefit, economically speaking. Which are my economic benefits? So in Italy, and I dare say in Southern Europe, awareness can be raised by creating economic benefits, so driving people to enter an energy community, understanding that there's value, green value, and also ethical value in that, so that they can be convinced. Today in Italy, we have the incentives of share energy, and also in villages with less than 5,000 inhabitants, all installations entering an energy community get 40% non-refundable fund from the government. That is, you can reach 2-3 years break even on the investment. That is, a lot of private companies are interested in investing. The law also says that the incentives above 55% of share energy must be devoted for social purposes. That is, each megawatt can generate from 25 to 30,000 euros per year for 20 years for the community. So today, what's happening today? We are companies, we have small cities that are entering energy communities for business purposes. These generate benefits for the community, the money that can be used, for example, for paying retirement houses, for paying drivers of cars for school children, and so on. Then we will reach the citizen in terms of aggregating energy user. Each family has typically a 3 kilowatt of energy POD. But if you put together 1,000 families, you get 3 megawatts. So it is different. So the mechanism is complex. The idea of just having people gathering to create energy community is philosophy. Practically speaking, we have to rely on economic convenience, creating drivers for investment, aggregating customers, and then awareness will come. But we are not starting from awareness. Some community is being created because families or groups of citizens were interested, but it is just something ethically useful. Today, the driver is the business.
Mm-hmm. Well, time is fast running and we are a bit short of time, but we have Greg and he would like to pose a question. And also I would like yes, Sergio wants to move to another event. Thank you very much, Sergio. You have to. Thank you very much for being with us, and we will make sure that we will have that day to discuss issues around this. Okay, we'll do that. It's okay. Go ahead. So please.
Thanks very much, Benedettos. So I'm sorry I wasn't here for the discussions earlier. I'm Greg Arrowsmith and I'm Secretary General of EUREC. And for me, the point of energy communities is that you try to balance locally, and you do that because if you have to export electricity, then you get paid a very poor price from your supplier. But supposing the attitude of suppliers were to change, and they started to pay a decent price, and on a cold winter's day when the sun is shining, then instead of being paid a few cents, you start to get paid a few tens of cents. You start to actually get rewarded for producing electricity at a time when the market needs it. Then presumably in that scenario, the business case for energy communities starts to look a little bit weaker. Do you agree then that if a supplier chooses to be less greedy, that could be a threat for energy communities and for the logic to create them?
Yeah, who would like to address this question? Yes, please, Magnus.
At least I have one perspective that can try to answer it. So I think what you're mentioning here is based on the premise that people are producing or having local installations that produce energy, and you get much higher revenue from that if you use it yourself rather than exporting it. And this is the role of energy communities is to have more people to share it so that you don't have to export it to the grid. And yes, this has been one motivation to form energy communities. And if that is the only motivation to form energy communities, I would agree with you that then incentives for forming energy communities are diminished by that. But I would argue that there are more reasons for forming energy communities. And I think an important reason is this grid issue, that you are increasingly challenging the grid, both in terms of more production, but also in terms of more electrification of demand and more new demand as well in the system, and this has to be handled somehow. And I see a role for energy communities there to contribute to locally balancing the energy beyond only taking care of excess generation. We can use it also in situations where you don't have any generation to use flexibility in a more clever way across stakeholders. So we have seen in research that I've been doing myself is that if everyone are just optimizing by themselves and everyone has a battery, the outcome is not that good. But if you have a community level battery or you have coordinated flexibility in the community, you can do much more with much less resources. So I think the main value of energy community is this, that you can coordinate across stakeholders to get a much more optimal outcome on a higher level in the grid. So yeah, I think we need to consider that there is a broader portfolio of value creation that can come from an energy community.
Yeah, thank you very much, Magnus, for that. I think the question that Greg has posed is a very important question that we need to answer. And because prices in electricity or the energy prices is not something that is just made, is greediness or whatever. It's maybe there is greediness out there, and maybe things are not realistically cost reflective. But I think at least from what we know and what we have investigated and what we have evaluated, the lowest cost energy production and use is what is generated within the energy communities. And that is the answer. Because the prices that we see in the market out there, okay, they are sometimes and many times they are made up. And you said they are made up from greediness or whatever. But there are realities behind them. And I would definitely agree with Magnus that there is a variety of benefits of having local generation, local utilization, local collaboration and cooperation on the resource is the lowest cost solution. That's why they will survive. That's my opinion. Some last words because we're finishing now. Huh? We would like Mara Laura to say some words from Selene and from surely Christina and Maria because we are finishing this event. Thank you. Yeah, please.
Yeah, maybe trying to address some of the comments that I've made. Yeah, energy communities can be a novelty. I think in Europe, especially in some places more than others. Happy to share about the best practices and the experiences that I can, of course. The enthusiasm that there can be from the energy community sides needs also to be matched. And I realize as DSOs, we have maybe a more realistic sometimes or over-realistic approach. If there are some gaps and unclarities, as DSOs, we have certain responsibilities towards all connected customers in and outside communities as well, and this needs to be kept in mind. So a certain ground needs to be posed before. Of course, here the cooperation and coordination and all the nice words we have put forward together are super important. So this workshop today proposed by Sergio needs to happen.
Yeah. Thank you very much, Selena, for your last words, and thank you for being here with us and sharing the DSO's view. Mara Laura, you are distant, but your voice is heard well. Go ahead.
That's great. Just a few words also from my side. So I was totally aligned with what Sergio said. I also think that actually for really, fostering energy communities deployment, the socio-economic approach is needed in the sense that I'm fully aligned that community users need to understand the economic benefits that they can have. But for having these economic benefits, of course, I think that the tools energy management tools, such that the tools developed in eNeuron are really important because, of course, you need to optimize, for example, what we have in Italy. As Sergio said, actually, we need to, for having incentives, you need to optimize the shared energy. You need to maximize the shared energy among the community users. And so for having that, of course, you need, let's say, optimization tools, you need energy management tools as the ones that have been developed by eNeuron. So here, just let's say a couple of words to highlight what, according to me, is needed for fostering the deployment of energy communities, but on the other side, what eNeuron, of course, has offered to this and can offer in the future, of course.
Thank you very much for these nice promises you give to the technology evolution of eNeuron. Thank you very much. Magnus, your last words for this session.
Yeah, I think a lot of interesting things has been said, and what I'm thinking about is we're seeing that the industry has been moving quite a lot in the last at least 5 years. I think that's when I started doing my PhD, and I discussed these kind of things with DSOs and other industry stakeholders. They were not that interested, but when I see now, today, the landscape has become quite different, and they're interested in these kind of solutions to solve real problems that they have today. And I think in that landscape, I think energy communities has a role, and it's even expanding as we move on because of the lead times and also uncertainty regarding what kind of infrastructure needs will we have in the future. We don't know, okay, but we can implement local solutions faster. So therefore, I think from a business perspective as well, the energy communities will have a role. It's not one solution fits all. It's not the only solution, but in the range of solutions that we need to address the electrification and shift to a more greener energy system. It's like it needs to be a part of the overall toolbox.
Thank you very much, Magnus. A very positive reminder that technologies are evolving very fast. I mean, in a very short time, we have seen so much change, and that's very good. Christina.
For many issues to be raised, especially about how we capitalize good practices and lessons learned from projects like eNeuron and how we move forward, having in the same table different stakeholders sharing their perspective. Thank you.
So being a technical coordinator, are you happy with the outcome and results?
Yes, yes, and everyone has contributed to it, so I'm really grateful and happy, yes.
Thank you.
Thank you.
Chief, Maria?
Thank you.
Go ahead.
If I should summarize in a sentence the message of this day, I would say, even if from different perspectives, all of us think that renewable energy communities are the transition enabler that Europe cannot afford to miss. With the different fast, with the different final benefit, and I think that eNeuron has contributed to this goal. So I'm very happy. And also, I take this opportunity to thank all of you for being here today. In particular, special thanks to our speakers and to remotely connected or here in presence, and to Venizelos for the moderation of this very interesting, in my opinion, roundtable. Thank you.
Thank you very much, Maria, for that. Chiara, you have a last word as well. I think you've been running in the background, so please.
No. Thank you, everyone, really for being with us. And it's with great pleasure that we end, I think, this project after so many years. And we invite everyone to keep following us on social media and on our website to see more and to really delve into eNeuron. Even though the people here with us, you already have our best practice book, so that's nice, I think. So.
Thank you very much, Chiara, and thank you all for being here. Thank you.
Of course, people in the room, there is the lunch now, so you are free to go and enjoy. Thank you. Si è spento. Ah, no. Okay. Guys in the room, if you want to came here, we take a picture before I leave you for the lunch or for your other engagements.